Microsoft. Uh, cool stuff I've done. I worked for Obama and I now work for Microsoft. The rest of this is on LinkedIn, so I'll just let you go there. Let's get to the fun stuff. Everything we're going to discuss comes from the white paper Polaris, the distributed SQL engine in Azure Synapse. So there's a link right here. Let me open this up and I will, if this does open up in a browser. Sorry, I'm checking my desktop for where that's going. And I'll throw that in the chat window. Oh, I got an error 404 not found. If you Google or Bing is fine, right? If you search for the Polaris distributed SQL engine white paper, there's multiple places where this is listed. So I apologize. Perhaps I need to update this, but the vldb.org was where this has been hosted for the longest time. So what we're going to do is we're going to talk about the road so far, where we are with modern data warehouses, kind of the evolution that we've had of the product. How do we access the Polaris query engine? It's a serverless SQL pool. So we're going to go through that, what it is, and then we're going to go back and forth, kind of talk about the T-SQL surface area that we have. Really just fantastic, the capabilities that we have to be able to perform very quick queries. And then I'm actually going to do a performance test using SQL Stress to kind of show the scalability of this engine versus the distributed pool engine that we have. So the three stages of the modern data warehouse site look like. We have our Azure SQL database. That's what we started out with in Azure. We have Azure Synapse Analytics. And now we have the Azure Synapse Analytics workspace where we have our serverless pools. We didn't necessarily have a specific icon, so I thought the workspace would be a nice fitting. So in the beginning, Azure SQL Data Warehouse. This actually technically is at the beginning. For those of you who may remember Parallel Data Warehouse, Parallel Data Warehouse was our first MPP appliance that we had. It used to be that you had to purchase the appliance and you could go from a quarter rack all the way up to a 16 node rack. When we used to have those installed, we would get all kinds of issues with customers, from needing to have engineers on site to be able to put new physical pieces in. One time we actually had a customer who, when we went to install it, they didn't have the physical racks. Another time we went, they had the physical racks, we had the engineers on site, everything we'd ever learned, we'd applied to this. They didn't have enough power in their data center. We had to delay the project by like 3 or 4 months while they ran more power lines to their data center to support the racks that we were going to stand up. That was kind of painful. Then we added a Hadoop cluster to it, and we started calling it the APS system, the Analytical Processing System. And then it became an Azure platform. And one of the things we realized is it was a million times easier for customers literally just to, in an Azure account, click deploy, set this up, have this running from our data center where we had everything deployed, and just be able to use it. This is the classic MPP structure that you're very used to. Queries come in and we hit a control node. We have an engine and our data movement service. We have a master database, which is essentially an Azure SQL database running as our master database. And then we connect out to individual compute nodes, and each of those compute nodes are running a separate SQL instance. But the really interesting thing is when we get to that control node and we divide up the query plan, we send it to compute nodes, they process, and all the power is in making sure that we're leveraging all these individual compute nodes to process something as fast as possible. And of course, all this is running on Azure Blob Premium Storage, which is why the IOPS are so fast. So stage 2, we just renamed things. Really, that was stage 2. I don't know if you remember, that was Ignite 2019. I had meetings with customers after we made some announcements to go, hey, today, nothing changes. The project we were working on yesterday is the same project we're working on today. There will be some things that start to come available after a private gated preview. And, but until then, we're not changing anything with what we're currently working on. We started calling the platform Azure Synapse Analytics, and SQL Data Warehouse became dedicated pools. Stage 3, this is when Azure Synapse Analytics Workspace went GA. Spark pools came out at that point in time, and we started to have the main selling point, as I like to say, of the Azure Synapse Workspace is the idea that I can work on notebooks on Spark, I can work on T-SQL on serverless, T-SQL on a dedicated pool, pipelines, Power BI, and all be sitting there within the same interface. But I can also use multiple different tools. As a matter of fact, tonight, when I show you the demos, I'm often going to be working either from SSMS or Azure Data Studio just to be able to show you that we can interact with the system. And you can really use whatever tool you would like to. But the nice thing about the workspace is it brings it all together. And we continue to grow features, right? We just added Data Explorer pools. So if you're looking at doing KQL, Cousteau queries, you now have the option to be able to have within your Azure Synapse Analytics, a Data Explorer pool where you could scale up to potentially thousands of nodes, use this for streaming data, use this for reporting within Power BI, and have everything connected within one place. All right, so how do we access Polaris? Remember, this is just a serverless SQL pool. I love this quote from Walt Disney, though. We keep moving forward, opening new doors, doing new things because we're curious. Curiosity leads us down new paths. In my personal opinion, the greatest thing that has come out of everything we've done with Azure Synapse are serverless pools. The serverless pools and the engineering behind them, really, really exceptional work. So let's just talk real quick. What have we talked about? We talked about the evolution of SQL Data Warehouse to Azure Synapse Analytics. And today we access the Polaris query engine when we use the serverless pools. So again, just to level set where we are before we kick off on the deep dive. Any questions here? I'm looking over at the chat. I'm going to take that as a no. And here we go. All right, so Polaris goals. When we started developing the Polaris engine, part of the goals were to be able to resize live workloads, deliver predictable performance at scale, efficiently handle both relational and unstructured data. We want to be able to be capable of handling partial query restarts, petabyte scale. Currently, there's actually a limit. It's lower than this. It's about 400 gigabytes per serverless pool. 10 terabytes was the initial goal. That's going to raise over time. But for right now, it's still about 400 gigabytes. And we wanted to have much more surface compatibility with T-SQL. That was one of the big issues that we had with dedicated pools. Constantly, people have been asking, when will I get this? When will I get this? And so we wanted to be able to have out of the box a lot more similar syntax to what we have. It's not 100% parity with SQL, but it's a lot closer. So the main features of the engine that we're going to go over are cell data abstraction, fine-grained scale out, combining scale up and scale out in the flexible service model. So this is where I'm going to, just read the slide for you real quick. So Polaris builds on the abstraction of data at the cell level to be able to run efficiently on a diverse collection of data, formats, and storage systems. The full SQL toolchain can now be brought to bear over files in Lake with on-demand interactive performance at scale, eliminating the need to be able to move files into a warehouse. This reduces costs, simplifies data governance, and reduces time to insight. A lot of nice words. What does it mean? So what this means is with Azure Synapse Serverless Pool, we can actually access multiple different data formats: CSV, JSON, Parquet, Delta Lake. Cell abstraction means we need the engine to actually be completely abstracted from the data type. In a dedicated pool, you load data and you have a proprietary type of storage. With cell data extraction, it allows the query engine to actually operate on a multitude of different storage formats. And so that's what we're looking at. We're looking at how can we support multiple different file types. So this is something that appeals to multiple customers and gives you multiple different types of capabilities. If you have a REST API and you're going to load that via a pipeline so it lands in your data lake, and you want to be able to look at that JSON data and see what structure and format it has, you can use a serverless engine to be able to pick that up. CSV files, you're looking to see, are they all in the same format, or I want to query one file in particular and take a look at why it's different from others. SQL Serverless could do that. I want to be able to query Delta Lake and I want to be able to get some of the latest changes. Serverless. I want to be able to read Parquet because maybe that's the format we want to go with because it's columnar and it's compressed. It preserves data type and column headers. I can also do that with serverless. So some of these are formats that are supported and I can import into dedicated pools. Some of them are not yet there for a dedicated pool. But one of the nice thing as well is with serverless, I don't have to load that anywhere. Once I transform it and I have it in my final state in my data lake, I can just start using it. So what we really need is that capability to be really, really flexible. Fine-grained scale-out. Highly available microservices architecture is based on careful packaging of data and query processing into units called tasks that can readily be moved across compute nodes and restarted at the task level. Widely partitioned data and flexible distribution model at a task level workflow data acrylic diagram or data acrylic graph is a novel and spanning multiple queries to contrast a framework for finer grained monitoring and flexible scheduling of tasks. Okay, so the key thing there is the way that servers have traditionally worked in the past. Here's our server, right? And if something goes wrong with our server, it crashes over and it's just down. And we have all kinds of things that we've invented to be able to come up with, to be able to make sure that we could come over that limitation of a physical box. We have clustered applications, we have load balancers, SQL always on availability groups, multiple different ways that we have figured out to go, how do I make this one server highly available? But at its core, on every single box and server itself, what we really have is a service running. We have the SQL Service EXE. And in some cases, we might have two portions of the EXE running. We might have additional EXE services for our scale out, something like that. But at its core, SQL Server, the query optimizer, the relational engine, all those individual parts are all sitting there in one EXE that you could kill. Or if your box files over, we need some other fancy way to be able to make sure it's still highly available. So what we need is we need a microservices architecture. In a microservices architecture, what we do is we recode the individual components that actually would make this up. You would have a service that would be your optimizer. You would have a service that would be your TDS layer. You would have a service that would be your query compiler. You would have a service that works as your buffer manager. And that constantly scales. So if I have something that crashes, I just spin it right back up. Microservices architectures are most commonly thought of with Kubernetes and pods and the way that we would actually deploy and develop. Kubernetes, typically I can have multiple different pods. I can have blue-green distributions to be able to have live content pushed to production to be able to deploy to my blue environment, cut over via a load balancer, and so that my green is now my secondary, and then do a code push to green. And so that way I'm constantly got services running and everything is marked out. So that way also, if I have an issue and I need to scale, I can just scale up and have more compute and more processing to be able to continue to do the same workload. Query optimizer is overloaded. Well, let's just spin up more query optimizers. IOPS is overloaded. Well, let's spin up more processes that run the IOPS distribution for threads. This leads to some really, really cool things that we can do with scale up and scale out. Now, the official definition of scale out and scale out is production-ready scale. SQL systems offer excellent interpartition parallelism. Then they have been finely tuned for interactive queries with deep enhancement to query optimization, vertical processing of column or data positions, careful control flow, and exploitation of tiered data caches. While Polaris has a new scale-out distribution query processing architecture inspired by big data query execution frameworks, it is unique in how it combines this with SQL Server scale-up features at each node. We thus benefit both from scale up and scale out. So what we mean by this is when you separate this to be able to get to the state where we've got scale up and scale out. If we say our on-premise architecture is over here, again, in one SQL Server instance, I'm going to have my caches, my metadata, my transactions, and also my physical data. This would be where we went with SQL DW, where we took the data and we detached it and we said, we're just going to have the compute. We can scale that out with multiple nodes, but we need the physical data that's going to be separated, and we can do something really cool with this. Now, when we start looking at what we've got with our serverless SQL pools, what we've done is we've separated, we may have a collection of, oh, I just clicked next a whole bunch of times. Well, that spoiled that reveal, right? I have a whole bunch of caches. I have metadata separated from compute. I have transactions separated from compute. And then my physical data is also separated from compute. This allows us to be able to scale out this metadata, the transactions, as well as the data as well. The data we can partition on our data lake. We can use a technology like Parquet or Delta to be able to deliver columnar level performance that is highly compressed. And then we can also partition that to be able to have a structure of, say, year, month, day, week folders. So the architecture that we're really looking at here, the way it's working is we've got these centralized services with metadata and transactions. Each SQL Server front end essentially has a distributed query processor and a control flow. And then within here, we have all these individual little tasks where we've got an execution service, a SQL server, and our cache specifically for those tasks. And then we have our collection of data cells. Again, this is going to be our user partitions and the way that we set these things up on our data lake store. We may have the partitions where we're doing our year, month, day, and typically underneath the day, we're looking at our loading pattern, right? If I'm loading once a day, I just need to go down to day granularity. If I'm loading every hour, I need to go down to hour granularity. Every 15 minutes, 15-minute granularity. And typically that's how I'm going to structure my data lake. That may be how my raw data comes in. So I can take just that incremental data, process that to my silver layer or my gold layer, whatever the ending layer is that I need to be able to have this data in its state. And then when I come in and I read that with serverless, I'm reading that silver or that gold. And I may even be using those partitions and those hierarchies to trim the level of data. Again, scaling up and scaling out. The most efficient transaction I can make is one where I'm getting exactly the data I want, and I'm not pulling in all this extraneous information that I then have to filter out to be able to deliver the end result that we want. So it's a combination of how we'll architect our data lake, as well as the front end is already architected and highly distributable for us. So some of the gains in functionality are the resistance to failure and the control flow. So this is our data channel. These are our tasks. The control flow is working. If all of a sudden I lose one of these pools that my tasks are working within, I can just spin them back up. And so that way I continue to be able to have functionality, or I can reallocate them. Sorry, I clicked too quickly to be able to put the task amongst all the controls that are currently working. Again, because the metadata is separated out and the transactions logging are separated out, it allows us to be able to reallocate these quite quickly. Hotspot recovery. If I have an issue with one individual place, I might be able to take and redistribute a couple tasks on nodes that can handle that additional functionality. For auto scale, I can do auto scale up, auto scale down. I get some new tasks that come in. I see that I'm evenly distributed and I do not have the space to be able to continue to take new tasks. And I will scale out to be able to process this. All right, so I just went through a lot. I'm going to start going through demos. Any questions about this? I put everyone to sleep. You're all sleeping remotely right now. I get it. It's 6:55. Either that or you're already done with this and you're drinking. Hats off to you.
Yes, I am. We're all shocked. Dear.
All right. So let's start with the demos. The first thing I'm going to do is we're going to start with some T-SQL. I do have Zoom it on. Sorry. This is, or maybe I don't. Sorry, I had to reboot earlier today. So I'm going to start out by just saying, going through all of these. Remember, in serverless pool or in a dedicated pool, I can't use, let me change the connection, reconnect here. I can't use master and then select a database. So as you can see, I've got multiple different databases that I've created within my serverless pool. Some of these are lakehouse databases, but I can create a database. I can apply basic level Azure security to it as well. I can create different schemas. I can deny access to a schema. I have a whole lot of control in here. If I wanted to use a database, I could just come down here and say, use Live 360 Go, select star from master databases, sys.databases. And you can see right here, I've just done a cross database query. For serverless, no problem. That's a really big deal for dedicated pools, not there yet. And that's something we'd really like to be able to have. So what version are we running again? We're running SQL Server. Come on. There we go. So it's Microsoft SQL Azure, even though we're running on a serverless pool. That's one of the core things to keep in mind is this is still SQL. So there's very, very low overhead in beginning to use your serverless pools. What about DMV support? Select systext, wait type, last wait type, start from sysdmx request, cross-apply sysdmexec SQL text for my SQL handle. And I can see this came back just fine. I had a memory allocation extent. And there's my SQL text. Select all from dmexec request history, order by start time. This is a really nice one. We've actually got a DMV based off execute history, and you can come in here and you can take a look based off the time. If I want to make this ascending, I can go the other way because I've been running queries in here for quite some time. You can see this goes back to March 29th at this point in time. And then this is Marcelo Silva. This is one of my coworkers who has access to my system as well. And so I can see who the login is. There's a T-SQL login that I'll be using tonight. And then our individual email addresses. So nice DMVs that we have. And then of course, one of my favorite, select from sysexec dmexec request, join with sysdmexec sessions, where user ID is user process equals 1. And I can see here session 99, which is what we're currently running under.
Can you zoom in a little bit, Brad? If people hear me.
Oh, sorry?
Can you zoom in a little bit? There.
Yeah.
It's kind of hard to see this. Maybe just 15%. There we go. There we go. Thanks.
No problem. The main concept that I really want folks to get is a lot of the T-SQL that you're used to using for Azure SQL that you may use on your on-prem SQL server, you can use within a serverless SQL pool. There are some exceptions. You can do a CTE as long as it's non-self-referencing. If you want to do that, you can actually do some interesting things in the master database because again, it's an Azure SQL database, but I don't recommend that for production code. So let's go a little bit deeper with this. I've got another notebook. Let's go ahead and connect. And what I've got in, hold on, find my. So this is my Azure Synapse Analytics workspace that I'll be using tonight. And in my Azure Blob Storage, I've got a lot of different data. And I have this folder, Layham Pipeline, and I have all these different data tables essentially that I pulled over from an Azure SQL database, and then I've stored as Parquet data. And then I created some views on top of them. And you can see the syntax that I'm using for each of these views is essentially from open row set. Then I'm using the bulk, and then what I'm doing is I'm specifying specifically where I want to go in my data lake. In this particular case, this is my my storage account right here. This is my container, and then this is my folder, the Layham pipeline, next folder appearances, and then DBO Parquet. Now, if I wanted to structure this as a year, month, day, I could absolutely do that. I could also take the data, extract it, and I could then by year say, maybe I only want appearances for 2010 through 2015. And I could do that using where predicate values. But the nice thing is I could do all that as I create the view, or I could just create the view and then query it. Because once it's a view, it's going to present to the end users as if it's just a regular view within the database, almost as a table. You can also make external tables, and we'll do that in a little bit. So let me, oh, not the external tables. Let's see, let's do the views. So here's all the different views we've created. If I come back over, I run this. Each of these is going to answer a question. Which team was the only club to hit 250 home runs while notching fewer than 1,000 strikeouts? The Baltimore Orioles. I just realized I've got those showing. Who was the MVP of the 1986 championship series? And you can see the T-SQL I'm running here. I've got to select, I'm appending two columns together. I'm doing an inner join on people and teams. I'm sorry, batting teams, awards players. I've got a where predicate value where an ID equals NCLS MVP and where an award year is 1986. Mike Scott of the Houston Astros. Again, taking a look at this, the syntax that I have, Alcline's best finish in the AL MVP voting was second in both 1955 and 63. Which two Yankees won those years? You run this. We've already got an answer. But again, I've got my inner joins. I've got my where predicate values. I've got an or statement within here. And it was Yogi Berra and Elston Howard. Which three sluggers hit 300 home runs or more in the 2010s? This is a really great one because you can see I've got an inner join, I've got a where, a group by, a having some, an order by some, and very quickly it returned Giancarlo Stanton, Nelson Cruz, Edwin and Serrano. And then if I wanted to look at what players had 5 home runs during the postseason of 2010 and 2018, I get the entire list very quickly. And again, you can see this is, pretty standard T-SQL that I'm using right here. So next up, what I want to do is I want to do a little bit of a performance test. So I've got, walk you through this real quick. So what I did, I've got these 2 different endpoints. Let me show you how I got these real quick. So when I go into Azure, I'm going to go to Azure Synapse Analytics. And here's my workspace right there, bball.asw. And in this header information right here, you can see I've got a dedicated SQL endpoint. I've got a serverless SQL endpoint. So if I take these and copy them, this is what I'm using to be able to put into SQL Server Management Studio. It's what I'm putting into Azure Studio Developer to be able to connect to these directly. And I can use a SQL authentication account or my Azure Active Directory. So what I've done is I've connected over here. And you can see this is my Microsoft login that I've got to my dedicated pool, and this is my serverless pool. And then this is the serverless pool connected via the T-SQL user. So for the serverless pool, I created a user and I gave it data reader. Same thing for the dedicated pool. Created a user, gave it data reader. So I wanted to match this up as best I could. So in the dedicated pool, oh, no, I'm sorry, this is the serverless on demand. You can tell right down, nope. You can tell right down here because of the on demand in the connection string name. So what I did was I used the database I created. I had to create a master encryption password. And then I created a database scoped credential. This is using shared access signature. And the way I got this is, let me go over to my storage accounts. So my storage account, first off, let's see, for right here is, oh, it's going to be in here. bball ADLS G2. So I'm going to go directly to that Data Lake Gen 2 storage account. What I did was I came to the shared access signature. I checked container and object because I want to be able to use both the container and the object. And what I did was I generated a SAS token that's going to expire tonight. And so this SAS token, you take off the question mark. I'll be honest, I don't even know why we put a question mark on here because we have the URL and all these other things that come as different services. And the first thing that I will tell you is that we want to delete the question mark before we use that in our SQL syntax. So I put it in here and I create this database scope credential. What this database scope credential does is it allows me to create a data source that uses the permission of this SAS token so that I can access that. That's important because I'm using SQL authentication through a serverless pool. If I was using my Azure Active Directory account, it would use my permissions and it would say, oh, does your Azure Active Directory account have access to the storage layer? In this case, it's a SQL account. There's no way for it to really go, hey, does your SQL account live in an Azure storage account? That's not possible. So what we need to do is create this database storage account to be able to use this database scope credential to authenticate our SQL user. The next thing I do is I come down here and I create an external data source where I'm pointing to my location as bball ADLS G2. So coming back over to my Synapse Analytics workspace. What I'm going to do is I'm going to use my baseball folder for this. I've got a roster folder and it's got a whole bunch of files. It says .ros, but they're actually CSVs. And I've got about 2 pages worth, relatively small files, not huge. And what I want to be able to do is I want to be able to create a foot race. So I'm going to come down here, create a CSV data type for my external file format. And then I create this baseball rosters table. And I'm using my data source right up here that we created demo to. And you can see that the way I'm authenticating to my, my data lake storage is with this credential. So I come back down here and I say with data source demo 2, baseball roster. And what I'm doing by leaving this open like this, I'm getting every single file that's under that roster file. And I'm saying CSV format, baseball, because I need to be able to define my external format for this file type. Now this is an externally defined table. We've got all our data types defined, and I wanted this to be exactly the same for serverless as we're going to use in the serverless in the dedicated pool. And then what I did was I said grant references on database scope credentials, live 360 demo. That's the name right up there. And we're granting that to the user recreated SQL balls. And so then what you would do is you take this select count from baseball rosters, you would connect as SQL balls right here, go to live 360, and we'd want to validate that we could run this query. And just to double check, if you look down at the bottom, wow, zoom in is having an issue with that. Hold on. Let me zoom in. There we go. There's our username, SQL balls, and there's our on-demand instance. So we can tell we're definitely connected to there. It took about 7 seconds for this to come back, and we've got 6,340 rows. So this is what we've got created over on our serverless pool. For our dedicated pool, and this is a DW1000. Again, I want to try and make this foot race as even as possible. SQL Live, configuration, performance size, DW1000C, max 240 terabytes. Don't worry, we're not even close with this. We're good. And so what we're doing here is I created an encryption, a master key for the encryption. I created a database scope credential as well. I then created an external data source. The format is a little bit different for a dedicated pool than it is for a serverless pool. And then I created the external format, CSV baseball, exactly the same as before, same table. Now, the big difference here is with a dedicated pool. Remember, we're not going out to proprietary. Well, we're going out to the data lake, but we're doing this under the auspices of this program. So if I create a SQL user, there's nothing special I need to do to use this external table. It can just use it. So we'll do a quick select count for baseball rosters. Comes back, sub-second, 6,340 records. So we've got the same amount of records. And then what we're going to do is we're going to go over to a VM that I've set up. And in this VM, I'm using SQL Stress. Now, this is a somewhat altered build that I have because the number of threads on SQL SQL Stress or Query Stress, sorry, the max number of threads you can get to is 300. I wanted to get past this because what I want to do is I want to take our thread count up slowly up until the point that we kind of tip these things over. So I understand what the performance is from one side to the next. I just realized looking at my camera, looks like my lights are off. So let me turn those on. Well, that didn't do a whole lot of good. Sorry. So it looks like I'm sitting in a cave, but yeah, sorry about that. Anyway, so we're connected to this. Here's the query we're going to run. And then what we're going to do is we're going to go over to the serverless pool and see how that handles it. So I've got my setup already in here. I'm going to test my connection. It's good to go. So we're just going to start out, let's say, with 50 threads. Oh, sorry, this is iterations. We're going to start out with 50 threads. And I know exactly what's wrong. This is trying to collect statistics time and IO. Let's run that again. There we go. Now we're processing. So we can see the number of active threads we have going on, the number of iterations completed, client seconds. Okay. So 50 threads, it did that. Let's up this by 100, right? 150. And this is our dedicated pool. Oh, and thank you, TJ, for answering that question. So we're processing. This virtual machine, by the way, is in the same region as the Azure Synapse Analytics, so I would hope that it would be able to process this load. If I start running this from my desktop, we're going to get some latency, and at that point in time, we'd get connection failures a little bit earlier. But again, what do you want? You want to make sure your application and your data source are sitting in the same Azure region. So we're following best practices for this. All right, 150. Let's up this again by 100. All right, we've got our serverless, our dedicated pool, 250 threads. DW 1000. So the question is, could I have done this in Synapse? What I'm trying to do is create a number of concurrent connections, a number of threads. In order to do this, I would have had to have 250 different query windows open that would then take up individual threads. And technically, I am doing this in Synapse. I'm doing this against a dedicated pool in Synapse. I'm just using SQL Stress to be able to take a look at this and see what level of performance we can take. Fernando, did that answer your question? Sorry, I'm trying to look. I've got you over on this monitor right over here. I see the thumbs up. Thank you.
Thank you.
No problem. All right, so let's go up another 100, 350. 350 threads on the dedicated pool.
Hey, Bradley, let me ask this question quickly. You are running that select star concurrently?
Yes. So if I were to go look at the CPU, I should be hitting some pretty high CPU, and this is concurrent threads that are executing on the system.
Are these hitting the cache, the results of caching?
No, I have result set caching turned off. And that's a great question, because that's one of the things I wanted to make sure when I was going through this, that the result set caching was turned off. I'll be honest, if this makes it, this is going to impress me, because this is where it failed when I was testing originally. So far, we've gone through it and there's been no exceptions. You can see that our seconds in iteration, though, is starting to climb. We're up to 30 seconds in iteration. 34, 35. Oh, we may make it through this. Right. 450. We're in new territory here. Typically, this was actually failing for me when I hit 300. So the fact that this is still going is somewhat impressive. Of course, it's going to steal my thunder completely if it gets up to the same level that a non-demand pool can process. Oh, there we go. There's our failures. We've already got 80 total exceptions. If I take a look at those exceptions, it's going to present as a timeout error. Timeout error, timeout period elapsed prior to obtaining a connection from the pool. This may have occurred because all pooled connections were in use and the max size of the pool was reached. Let's just minimize that, close that. Now it did process a majority of this. That's very impressive. See if we get any more failures or if it was just going to be that bulk that we hit right there. So 450 is where we were defeated for the on-demand pool. Or sorry, for the dedicated pool. Now we're going to go to on-demand. Going to go to Live 360, test the connection, click OK, and let's go. Or 19 to go. Now, again, in my original testing, the dedicated pool was actually falling over around 300. So it was impressive that it made it to 450 before we started getting failures. And it was pretty consistent earlier today that 300 was the number for it. But remember, our client iterations per second were up in the 30 and the 40-second range. These client iterations are around 16 seconds, and we just processed 450. So let's go ahead to 550. So this is going to be really interesting, because notice these iterations per second are lower than the 16 seconds, what they were when we were running at the 450 range. So we just processed more and we got faster. That's kind of interesting, right? We processed more and got faster. 650. Now this is where things fell over for the serverless pool the last time I was running. So I'm going to be curious to see if this also gets a little bit better. Yep, okay. So we got 93 exceptions. If I take a look at those, same error as we got with the dedicated pool. For some reason, the notepad is not coming up. There. Oh. We had it for a second there. It's the exact same error. I tell you what, I'm not gonna struggle with that. So 450, and again, typically earlier today, this was falling over right here. I could process 600 just fine. 650 was where I hit my limit, but earlier in the day, the dedicated pool was falling over at 300. Today, it made it to 450. But one of the things you'll notice is that our average second client iteration was much faster than the dedicated pool for what we were processing. Now, again, we're just doing a count, we're doing it against a system. As you make the queries more complex, serverless pools actually have a query gateway very similar to SQL Server, where there's a small, medium, and large query gateway. So we're using that small query gateway where we've got a lot of them. If you start going up to a very large query gateway, we're going to be able to get fewer iterations of that as it scales up. But this also right sizes queries, where we've had to do a lot of work in dedicated pools to be able to do workload settings, make sure we were in the right resource group. We don't have to do any of that with a serverless pool. To me, that makes this something that I watch very, very closely. I think we've got some really great things coming from the product group. Nothing that I can talk about, sorry. But if I were a betting person, we just had Build. And we had some really cool announcements, but nothing specifically on this. So I always say, look at our major conferences for whenever they come out. And our next one should be Ignite. If there's going to be any announcements, those will be the announcements we get at that point in time. But as you can see, dedicated pools, their architecture, incredibly powerful stuff. All right, so some demos for afterthoughts. What does this mean? Remember, serverless pools, the price is $5 per terabytes processed. And as a matter of fact, let me just kind of go and show you this real quick. So if I come over here to monitor and I look at my SQL request, I can see all these different queries and what their size process was as I ran through them. I look at my built-in. I'm not sure if it'll charge me right now. Yeah, you can see so far today, I've processed 355 gigabytes. I did multiple presentations today using SQL Serverless, and I tested this demo multiple times and just ran it for you again. And keep in mind, we were running, 650 concurrent queries, running the same 85 megabytes over and over again. I'm not even at $5 yet. I'm not even at $2.50 yet. This is an incredibly flexible system and an incredibly cost-effective system. As a matter of fact, I had a customer and we looked at serverless pools, dedicated pools, and Databricks as an architecture type of pattern that we were going to use to service up our queries and process them to analysis services cubes for tabular, for reports to be able to go against the AAS cubes. The Databricks was 25x more expensive than the serverless pools. The dedicated pool would have been 10x more expensive than the serverless pools. The amount of money that we saved on that project was absolutely massive to this customer and allowed them to increase the scale and the scope of what they were looking to charge just because they were able to use this tool so effectively. Now, this isn't a cure-all, right? There are reasons to use a dedicated pool, highly indexable. I can make sure to be able to divide this up amongst my nodes very, very clearly. There's a lot of query tuning that I can do to be able to make something more performant. I can't really do that with serverless right now. We're waiting for execution plans to be able to tune them, but even when we do, there's no indexing structure I can put in place. If I want to pull 400 gigs from a folder, I'm going to be waiting a while, and that's going to take some time. So loading into, say, tabular analysis services, that might be absolutely fantastic. If I have a massive amount of data and I need to do a lot of transforms, I'm probably going over to a server, to a dedicated pool and using a materialized view. So there are reasons to use a dedicated pool still, but serverless pools are coming along, and I would not be surprised if we close the gap at some point in time and we're using this serverless architecture to be able to serve up things that potentially have, additional features that make them just as functional. We have hyperscale indexes right now that we can use for Spark. I I don't have any knowledge that that's going to come into play for serverless, but I would imagine at some point in time, we have some type of engine that allows some additional flexibility, which would be really awesome. All right, so we have data scientists who can use this, and here's some things to think about. I have multiple customers. You get a serverless pool per Azure Synapse Analytics workspace, and you can have up to 20 serverless pool or analytics workspaces per region. That's a soft limit. If you really need to go more, that's something where we could talk to the product group. But I would say we need to have some really good reasoning for that. I've had some customers that had some really good reasoning, but most of the times 20 will more than do what you want to be able to do. So I could spread this out. So I could have a Synapse Analytics workspace with a serverless pool for my data scientists. And then I could theoretically also have one for my business users. I could also have one for my manufacturing, and then I could have one for my individual report users. And they can all use Azure Synapse Analytics to be able to hit the same Azure Data Lake store. As a matter of fact, I have customers, all kinds of customers that use this architecture to be able to point at the same data lake and then offer up that view and then secure their Synapse Analytics for each individual user. So that way they may have some data scientists who need to make pipelines, that might need to make notebooks, that might need to spin up Spark pools. But at the same time, maybe we want to have separate pipelines and we want to have separate notebooks, or we want to have separate reports that are in use specifically for our business users. Thank you, Oscar. Fernando, you work for the dedicated pool group. What's the center? Serverless pool? So the center of this is a data lake. So this is our data lake store. And what I can do, so for example, so for example, what I can do is I can have a data lake and I can have multiple Azure Synapse. Let me cut my camera real quick. See if that will fix this. My computer's slowing down a little bit. Now, Teams appears to have bit me. So, what this means is you can have an Azure Synapse Analytics workspace, and when you set it up, you can either create a new data lake or you can point at other data lakes. And you can have multiple workspaces, even in different regions, that can point to different data lakes as well. So I have some customers in Europe where they've got a Synapse Analytics importing data in one region, and they've got another region that is their main user hub. And what we've done is that main user hub, Synapse Analytics, also has a link associated with their data lake. Let's see if that works. All right. Yeah, I feel like I'm pretty frozen at this point in time. Sorry about that.
Yes, I can still hear you.
Oh.
Just your image is frozen.
Gotcha. Sorry about that. Now I have something hopped up in front of my. Okay. Yeah, sorry about this. I shouldn't have put on my camera. So essentially what I'm trying to say is you can use multiple Synapse Analytics to be able to point to that data lake. And within that data lake, each of those Synapse Analytics will have their own It
looks like if frozen, his computer shut down. So I'm going to stop the recording right now.